All right. Turn on the cameras, guys. Again, I see some people forget about the attendance. There are only 22 people as of yet here. Now, your first exam is going to be emailed to you. Okay, it will be due on the 29th of April. That exam is therefore a take-home. Just like the second exam, should it occur, will be a take-home. The instructions will be on the exam, but roughly what it means is that when you submit the exam, you have to make a single PDF file. You have to make it out of the form of the exam. You would receive a PDF exam. You can write your solutions in it, and you can submit a review for what? Review for the final? I usually give review for the final, which is beyond the time of class, since class is way too short. Now, some of you, I presume, worry, or maybe, well, I'm not sure if you are worried about such things. You worry whether or not you had first, second exam, whatnot. What I worry about is whether or not you understood or know anything from this class. A person that knows will not ever be failing. A person that knows, you can ask them any exam, any questions, and they answer those. Do you know? Junaid, if you are not on my roster, make sure to send me an email to Arkady Etkin at Yahoo with your first and last name, and I'll check it, okay? And say you're from the morning class. Clear? Any questions, guys? Anything you're worried about? Life? Do you have bad dreams? As I mentioned, there is something. We'll see if we do it in class if you get very tired, or afterwards. We still have tons and tons of things to cover, but I'll show you an instructional video on forklifters. All right, so we are now in a new topic, chain rule, lecture 1. You are all familiar with several functions. So for instance, you know how to take the derivative of x times sine x, correct? The derivative of x times sine x is simply the derivative of x times sine x plus x times the derivative of sine x. It's a product of two functions which separately you know to differentiate, correct? You know how to differentiate x, and you know how to differentiate sine, I presume. Now, guys, do you remember by any chance where I used to work before I was doing mathematics? Very good. I used to work in the New York Aquarium. And there at the New York Aquarium, that means if you go there right now, there are very, very few animals left. They began disappearing with my activity there. So this is what I observed in the New York Aquarium. And this is the type of fish you are familiar with currently. There are very, very few species. Here is your ordinary polynomial fish. You have the radical fish, the roots. You have the involution, the eel fish. You see, it looks kind of like 1 over x graph, at least part of it. You have the eel. You have your medusas, that's sine, cosine, all the trigonometric functions. Yes? You're familiar with those. And of course, let's not forget about the octopus, the exponential function. Now, when you go to the aquarium, you have to deal with children, and sometimes they scream such very weird things. Mommy, mommy, sine x squared, sine x squared. Yes, you hear such things. Now, could you tell me, please, what do those children scream about? What happened? What happened? What are they afraid of? or what has impressed their young imagination. Yes. But what is that, guys? What just happened? Somebody says, sine x squared, mommy. Sine x squared, what happened? Why are they excited? Remove the blinders, guys, wake up. Remove the blinders from your eyes and tell me, what are they communicating? No. Look at this aquarium. You can see that you haven't been going to the aquarium much. Here are the species of fish that are known. Yes, there are 5 types. Now look at it carefully. What is sine of x squared? If I say sine of x squared, what has happened? What has the child witnessed? Finally, God damn it, a fish has eaten another. A medusa ate a fish. Do you see that? That's what they witnessed. Could it be mating? I don't think so. It could be anything you want, actually, Francis. That's the point of mathematics. When is it exciting? Is when you read something and you see billions of interpretations, which are all true. Do you understand? One thing that excited me about abstract algebra, that you have this impression that, at least that's my analogy, that in the eyes of God, to be shot and to get flowers is the same thing. At least in some sense. You understand? So you see, the idea is that in mathematics, you are able to see things that look completely opposite, completely unrelated, and you see the connection between them. So here, in this analogy, it looks like, for instance, if I ask you to differentiate sine of x squared plus 1, what I personally imagine is that I fished up a medusa, and when I cut it open, when I fillet a medusa, in its belly, I see a common polynomial fish. You understand? So this type of function has been created when the medusa has consumed another fish. So you have only those functions. So you see how to break it down. So when you take the derivative of sine of x squared plus 1, you are breaking down sine and you're breaking down x squared plus 1. You see the ingredients that make this more complicated function. It's consistent out of just one creature having eaten another. Very simple. Good? So let's now see how to take the derivative. Unlike my other usual attempts to first present the theory, let me actually carry the calculation. We're going to calculate first and then understand why the calculation is correct. So the derivative of sine of x squared plus 1, you see what I think? Fillet the outer fish and you get cosine. And in its belly, you see x squared plus 1. Multiply by the fillet of the inner fish. And fillet is synonym for derivative here. Yes? So differentiate the outside function, find the inner fish, and differentiate it. Clear? This is what we get. The derivative of sine of x squared plus 1 is cosine of x squared plus 1 times 2x. Derivative of the outer function, in its belly you have x squared plus 1 times the derivative of the inner function. If you understood, I would like you to tell me, look at it, here it's sine has eaten x squared plus 1. Now tell me please in your comments, first, what happened here? So it's sine squared plus 1, what happened here? And second, what's the derivative? Okay, I especially want to hear what happened here. Sure. Cannibalism? No, it's they are not of the same species here. Cannibalism, do you mean somebody who smokes cannabis too much? So what's that? Well, thank you. Right, guys, obviously you can use other analogies, but I am just checking whether or not you at least understand my analogy. Christiana absolutely understands. Zvi understands. Do you understand the rest? You need to be able to see what happened. There is predation here, at least in my analogy. Good. So in that analogy, we have the common polynomial fish x squared plus 1 has eaten the medusa sin x. Good. Now, what's the derivative of that? The derivative of that is the derivative of the outer function. You, by the way, can just break it into summation. It's up to you how you do it. So it's the derivative of sin x squared plus 1. It's going to be the derivative of the outer function. It's 2 times times what's inside, times the derivative of the inner function, which is cosine. Derivative of sine squared plus 1 is 2 sine cosine. Do you see that? You could, and you can of course use addition as the main result. You can think of it as sine squared plus 1. Differentiating 1 is 0. Derivative of sine squared is 2 times sine x times cosine x. Do you, by the way, recognize this formula? 2 sine x cosine x equal to what in terms of trigonometric identities? We spent so much time with it. Do you remember trigonometric identities? What's that? 2 sine x cosine x is simply what? Just to see if you remember trigonometry. Yes, double angle formula. Humira, sine of 2x. Thank you, Humira. Thank you, Christiana. The result is the result is sine of 2x. Yeah, sine of 2x. That's just something that you should be, when you're comfortable with the subject, you see such things very fast. Okay, guys, here it's your turn. Now, I would like you to take the derivative of a, first of a. Just let's do a. Do it as fast as possible. And when you give me a response, I also want to see if you understand my analogy. What happened? What ate what? Yes, okay, but also what ate what? Well, yes, Christiana. You see what functions do I call medusa, Francis? I call trigonometric functions medusa only because their tentacles are wavy, and it reminds me of the waviness of sine and cosine, right? It's completely arbitrary. And e to the x, I just decided it's an octopus. There is no reason for it. Exactly, Tzvi. Okay, guys. So it's really the exponential, the transcendental function has eaten x squared. And now the derivative is what? Everybody tell me the derivative, please. Okay, Junior Hassan, I received your message in email. Are you there? Junaid Hassan. And also, guys, why am I not seeing a cascade of answers for e to the x squared? What's the derivative of that? I think I've seen like 3 or 4. So let's see the derivative. Come on. Very good. When I say good, I'm hoping you're not copying from comments, right? You're just thinking it on your own. So the derivative is e to the x squared. That's the derivative of the outer function. I just took the derivative here of e to the box. It's e to the box times 2x, right? Now help me with problem B, please. No worries, Giovanni. Glad to have you here. Hope it works. Derivative of tangent of root x is what, please? Okay. All right. Very good. At least what I see is good. So that means what? Here is the situation. Derivative of tangent is secant squared. Derivative of root is 1 over 2 root. Do you see that? So the chain rule is fillet the outer fish, find the inner fish, and then fillet the inner fish. Multiplication between the fillets. Good? Calculate C. Okay, but be careful. So you know you write it, Francis. Derivative of C. Thank you, Junaid. Careful, Junaid, by the way, you made a mistake. Derivative of secant is what? Thank you, Anna. Very good. Okay, so the derivative of C, here it is. Derivative of secant is secant tangent. So it's secant of 1 over x tangent of 1 over x times the derivative of the inner function, and that's the derivative of x to the minus 1, which is minus 1 over x squared. Good? Finally, can you do D? Okay, Francis, good. 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 So this is the situation. It's derivative of the outer function is equal to the derivative, so the derivative of the outer function, and then multiply by the derivative of the inner function. All right. Now, finally, my favorite type of questions. Why does it work? Why does the chain rule work? No, it's not part of the first exam. It's already second. It's information for the second exam if it is to take place. Yes? Your goal is the final, pretty much. That's the true measure of whether you know anything or not. Even that, I'm not sure if it's really a measure. But the final will be timed, and it will be theory based. So guys, why does the chain rule work? Okay, so what's the idea? We have one function, we know how to take the derivative of that function, and we know how to take the derivative of that function anywhere. For some particular f and g. Now, how do I take the derivative of g and in its belly f of x? How do I do that? Group chat. So why is there no point in joining? No, I'm not asking what's the derivative, but I'm asking how would you find it out, right? I mean, we just actually practiced and we know what the answer will be, right? But why is that going to be the answer? Now, help me figure it out, guys. When you don't know something, what do you go back to? You go back to the bedrock. And what's the bedrock here? You're asking me when you're having exams, guys, you should come early to class. That is always, I spoke about it for like 5 minutes. I'm going to send you the exam soon. It's due on the 29th of April. So you have tons of time. I mean, it's an exam that should be done in 1 hour, but you're getting a week to do it. What's the derivative and how do you find it out? Show me you understand. Yes, Christiana, I want to take the derivative of this new function. So this new function, let's call this new function, this new thing that I see, I call it kx. When I have a new function that I don't know how to differentiate, what's the bedrock? Where do I go? Where do we always go when we don't know how to differentiate a function, please? Finally, the definition of the derivative. Of course, you understand what's the purpose of any of it. You just go back to the very beginning and see what you can say about it. Okay, so what's the definition of the derivative? Let me just do it on another page. So the derivative of the function kx is limit as z goes to x. I can use this definition, right? Of kz minus kx divided by z minus x, which is limit as z goes to x of g of fz minus g of fx divided by z minus x. Now here is a true moment for you guys. You understand? You can figure out the formula if you know, if you can be that spell checker. You've seen in your phone, you type a lot of messages. You begin writing a message and the phone is offering how to complete the word, right? You wrote th and the phone is saying the, which means that there is a recognition of what is your intention or what might be the intention. So you see I have limit as z goes to x, and I write here g f z minus g f x divided by, and here is my question, guys. If you were that spell checker, what would you have written on the denominator? What would you have offered to autocomplete? You understand? You see this numerator. And then can you right away see what should have been the denominator to make this question very easy? Christiana. Okay, interesting. Wait for a moment. What should be on the bottom, guys? Everyone. You understand? All this time we're struggling with one thing. Can we recognize the derivative? Can we solve that peekaboo thing? How do I know? Come on. You have to think very deeply about the derivative, guys. Right? What is the derivative of any function? If I have derivative of m, right? What do I think of? I think m of box minus m of triangle divided by box minus triangle, where this is going to 0. That's really the derivative in my mind. Okay, Jahin? You understand, guys? My understanding of the derivative is entirely void of letters. Letters don't matter to me. And if you get that type of perception, then you right away see what should happen there. Letters are supposed to help you get the concept. Come on. I don't want to reveal the answer before more people have tried. Okay, Jahin. You understand? Void of letters. How do you recognize the derivative? Numerator going to 0, denominator is going to 0. Yes? Here is what I see more or less, right? It's the function at something minus the function at something, where that something inside of the function going to the other something. Okay. Let's go. So my good students see it right away, right? Correct, Humira, correct, Christina, correct, anyone else who said f of z minus f of x. Of course. Of course. Why? Now, if this were the situation, guys, if this were my formula, this is what? If I simplify it into the prime notation, what I circled in orange is what? The derivative of what at where? Yes, a derivative, yes, but of what at where? Z is just going to look at it. Z is not important. Z is going to x, right? Z is morphing into x. The derivative at what point? Where do you see 0 here? Christiana? Yes. Derivative at the point f of x of the function g. This is simply g derivative evaluated at f of x. Do you see that? Look at it. What's the box? You're just, again, you're not seeing this. Box, triangle. What's the box here? The box here is here. The triangle is here. Box is here. Triangle is here. Yes? Why is what like it? I don't understand your question, Francis. So this is the definition of the derivative at f of x. Yes? But we don't have f of z minus f of x. So what do? We multiply, but by the thing that we're missing, we multiply by f of z minus f of x. Do you see why? We cannot introduce, I call it wishful thinking, guys. If you know what you wish for, you can introduce it into the expression and you will get the right solution. You just have to know what you wish for. Yes? You wish for and you pay for it. And I can tell you it's true in life. Every single wish that I truly had that was truly from my heart always came true. And I always regretted it. So this is f of z minus f of x and divided by z minus x. Do you see it? I just introduced the f of z minus f of x, which if I see it on the left, I see the derivative of g. You see, I mean, forget f of x is just that point at which you take the derivative, but on the left, you see the derivative of g. And on the right, this is the derivative of what? What is this? This is reduced to what? Derivative at x, but of what function? Simply, you can write it in one in a few symbols. Well, the derivative of g is here, and the derivative here is of what? Yes. The derivative of f. My voice sinks into the bottomless pit, apparently. Reverberating into nothing. That's the definition of the derivative. Yes? So here is your chain rule. Look at it. Take the derivative of the outer function, evaluate at f, multiply by the derivative of the inner function. Do you see that, guys? If you adapt and understand what I'm trying to, if you are able to recognize, like Humira and Christina and a few other people are able to do, the subject is trivial. There is just very little in this particular topic. There, you see, that's pretty much what calculus at this level amounts to. Just recognize that you are seeing the same question again and again and again. You see, so there is very little to learn here. You don't recognize it, then there is infinity to learn here. All right, so there is, of course, there are many other ways of doing that which are fun. You can use, do you remember still the stun double, your favorite friend? Yes? You can use the stun double to, what's the stun double? Is that you zoom in on a differentiable curve and you see a straight line and you report the slope. You understand? So you can use the stun double geometric ideas to derive this exactly. You can do many things, you understand? You can use the geometry just like we did for other functions. It's a good exercise if you'd like to try to derive this using the stun double. You see, it's too bad. I have to give you so many questions. All right, so here is that situation here. We found that what's the derivative? And here I actually even, I spoiled your fun. Do you see it? Cascadeur, stun double. I actually carry out the derivation of the stun double. I even forgot. But you don't look at it. I mean, I know. You don't open my notes. So that's fine. You just do it on your own and you will have this discovery. All right, let's now continue with this boring derivative thing. Just calculate what's the derivative of A, please. Yes, very nice. Is it nice? I don't remember what was the function. All right, what was the function? 4x minus x squared to the 100. Yes? What's the derivative very fast for A? So let's see, guys. The outer function is the 100. So it's 100 4x minus x squared times the derivative of the inner function, which is 4 minus 2x. Agreed? And that's to the power of 99, not to forget that. Very good. Now calculate b, please. Sine of e to the x plus e to the sine x. What's the derivative? Okay. So the derivative of b is cosine of e to the x. Notice that's I took the derivative of the outside. I need to take the derivative of the inside. So it's e to the x plus e to the sine x times cosine x. Everybody sees it? Those are still easy. Good. Now, what's the derivative of c? Okay. Yes, and but Francis, you know, you have to then be careful. The 1/2. Yes, the inside would not, but then it has to be completed. That's S, of course. Yes. Robert, in your answer, somehow the quotient disappeared. Yeah. Oh, it's actually time to take a class photo. Say cheese if you want to be in the picture. Cameras on, be in the picture, who participates, who is here. Okay. Wonderful. I will hang those pictures on my wall. What was the reason for taking pictures? Oh, attendance. It's I don't waste time, you know, in the class writing who is here, who is not, who is visible, who is not. It's a nice, beautiful picture. Also, I have a German police officer friend. It's also to give him your information. That's good. Guys, so here is, of course, a good question. Do we simplify, guys? You're told to take the derivative. Don't bother doing with it anything unless you are using this function. You understand? You don't care about this function. It's just an exercise in whether or not you can calculate derivatives. That's all. Agreed? Okay, so first of all, how huge? Are you ready? this is now root inside of a quotient. Yes. So what's the situation? We can do it simply like this. The derivative of the root of s squared plus 1 over s squared plus 4 is 1 over 2 root of the function. You see, derivative of root is 1 over 2 root, or you can write 1/2 the thing inside of root to the power of minus 1/2, up to you. Good. This is the derivative of root multiplied by, now I can square the denominator, copy the denominator, multiply by the derivative of the numerator. I basically here apply the quotient rule. Good. It's very annoying to write it in the message. I obviously, you know, guys, all I hope is that you understand how to do it, right? I'm not moving too fast with such calculations. You understand how to do them, yes, guys? And in office hours, if you stay, that's the best place to practice it, of course, if you need my assistance. Good. Now, yes, if anybody needs anything else. Yes, well, here is for the final. That's why you have my regular exams to hopefully keep you up a little bit. But typing it up, you have last semester you had, I think, like first you select the solution, or there's going to be you know, symbols for root, symbols for division that you can apply, and the actual work you have time to upload, I think, like 20 or 30 minutes after the exam is closed. But you can also send it to me if it's going to be terribly messy. Good. Guys, worry about understanding, you see. So I can see here some people that I obviously see they are thinking mathematically. I can see maybe 5, 6 people that I can clearly, well, I believe they understand the material, that I consider understanding it. Okay. So I will protect anybody that I believe knows or is actually interested in learning. So D, please, very quickly calculate D. It's easy. Yeah, Francis, you're very fast here. Yes, well, it's only in T. It's correct, but only the letter T is here. Okay. You can do two things, guys. Either you type the solution for it, or you write easy, or easy if you want to spell the word, meaning that you understand how to do it and you don't need to type it. Okay. Yes, Christiana. Yes, Humira. Svi. Here it's not important. You just in general, you know that there should be parentheses about minus sign. Obviously, I don't comments. It's whatever, right? But you understand. Just always try to write it in a way that's very, you know, not just that in your mind, but it's completely grammatical. Yes, Robert, very good. Just you mean multiplication, because you see, Robert, what you wrote, a computer would have marked it wrong. You understand, guys? Have very good habits. For me, it's fine, but if it's a computer grading, or you have to also be technically correct. Very good. Very good. You understand how to solve this, guys? Then let's move to harder questions. Now solve E. It's sine of tangent of EX squared. Solve E. So Francis, you are fast, but the computer would have said you're wrong. You have to be careful how you type it. It's a bit annoying to type it here, of course. Very good, Svi. Which test? I mean, some of you are all obsessed about tests. What test? My test or the final? It's long and scary. You understand? It's very long and very scary. So you should all prepare and be in top shape for it. All right, here it is, guys. It is cosine of tangent e to the x squared times secant e to the x squared times e to the x squared times 2x. Just you continue doing the chain rule. Well, that's good, Giovanni. Of course, you should see pattern. So this is just calculation, guys. Those are kind of the lowest problems, the lowest type of problems, because you can just you can just notice this pattern and carry it on. But for instance, have you noticed, maybe if you study probability, you might notice that the same mechanism that has multiplication in chain rule is the same mechanism that multiplies probabilities. You understand? It's the same machinery. Now, what is F? We're getting to the hardest ones. What is F? Here we have it. The derivative of root of 1 plus x times e to the minus 2x. It's first of all, what do we have? We take the derivative of the root. It's 1 over 2 root. So it's, you see here on the bottom, it's 2 root of 1 plus x e to the minus 2x. And then on the numerator, I take the derivative of what's inside, and that is product rule. You see that product rule? Because it's the derivative of 1 is not important, but the derivative of x times e to the minus 2x, it's e to the minus 2x minus 2x. I made a yeah, no, it's 2x, that's right. Minus 2x e to the minus 2x. You see that? It's because when you take the derivative here, it's e to the minus 2x plus e to the minus 2x times minus 2. So times x here, of course, right? So that's how we get this numerator. Good? Yeah, I did product rule on the inside because inside involved product rule. Do you see? It's 1 plus x e to the minus 2x. So it's chain rule, but to execute the derivative of the inner function, I need to take the derivative of the chain. Now here is some more annoying question, guys. This one is a bit annoying. Root of x plus root of x plus root of x. Let's see if you can do this one. Angelo, you stopped appearing, I noticed. Ready? Yeah, it's a bit very annoying. I would not want to type it in the comments. I'm sure I would not have. So what's the idea? So I take the derivative of the outer root and I get 1 over 2 root x plus root x plus root x. So I just took care of the outer derivative function. If I want to, I can mark it with a red line to not forget that I carry the derivative. You see? Next, I need to take the derivative of what's inside the red line. And so I put parentheses. The derivative is 1 plus, and then I take the derivative of the root, right? The derivative of the root is 1 over root over 2 root x plus root x. Agreed? And now I took the derivative of the root over here. Now the chain rule is continuing from this root. You see, it's continuing on the inside. A 1 over, because the derivative of root is 1 over 2 root. So basically, I think if you take derivative of root, you get 1 over 2 root. Yes, just writing it differently. Then instead of writing the minus 1/2 power, I write it this way. I could write the minus 1/2 power, right? Right, so the 1 plus is because the derivative of the, I just multiply by the derivative of the inside. See, derivative of the root is 1 over 2, whatever is root of whatever is on the inside. Now times the derivative of what's on the inside. Derivative of x is 1 plus now the derivative of this part, of the blue part. Here I took derivative of it. So then it is what? It is now times the derivative here is 1 plus the derivative of root of x. It's 1 over 2 root x. Now I can close my parentheses. And I'm done. This is my answer. Let's make it just prettier looking. Good. Now, there is a much easier question. It looks harder, but it's actually easier and less confusing, guys. I want you to take the derivative of root of x plus root of x plus root of x plus root of x forever. What's the derivative of that? You understand? This goes root of x and root of x and root of x and root of x forever. What's the derivative? Of course, you see, that's the thing. You decide how to figure this problem. Yes, guys? Very good. Some people get it. Some people get it very well. All right. One person had the idea. How do you do that, guys? Look at it. The entire thing, let's just make it less scary. Let's call it a y. And look at it, this, because it's infinite, what's inside of this y is also a y. So we have, what do we have here? We have that y is equal to x plus y underneath the square root. Do you agree? You see, it's just y equal to the square root of x plus y. Now what do you do next? Root of x, I'm not sure. What's this? Y is the unknown. What's this? This is the full function. Y is a function of x. So what do we do next? We can square it. So we have that y squared is equal to x plus y, which means that we have the equation y squared minus y minus x is 0, which means what? What's y? In this case, because we haven't yet learned implicit differentiation, we are going to try to first find a much simpler formula for the function before we take the derivative. You agree? You see, we have one formula, maybe we can find another much simpler, and that's what we try. So y squared minus y minus x equal to 0. Solving this quadratic equation, you get y equal to 1 plus or minus root 1 squared minus 4 times a times c. So it's plus 4x divided by 2. As it appears the function is positive, we are going to discard the minus sign. You see, I applied the quadratic formula. So my understanding is that this function is simply 1 plus root of 1 plus 4x divided by 2. And what's the derivative of this function? The derivative of that function is very simply 1 over 4 root 1 plus 4x multiplied by 4. So it's simply, so the derivative is simply this. You got it? Yes? I mean, you see, you have to guess two things, guys. Don't try the calculations, you should be able to carry. Do you understand the idea? I see that at least a few people do, and without even my help, right? So you see that you can see the function is containing itself, which allows me to come up with a much simpler formula, and I can then differentiate the function when I have the simpler formula. And here I employ the quadratic formula to figure out that explicit formula for y. Good? So how are you holding, guys? Brain fried, or you're very well and strong and a lot of coffee? Write in your comments, because we are now embarking on another topic. And before I do so, I'd like to know how you are doing. Okay. I don't know how you would find what I'm going to show you now. Let's maybe have a brief interlude. Okay, so I'll show you a video 9 minutes long. I will take a few more minutes at the end of class to make it a 5-minute break. Good. And I don't know. I mean, somebody sent it to me, possibly knowing my my inclinations. I don't know. I already saw it twice, so I don't know how it would affect me again. But let me show you what I mean. Give me a second. Where is it? Oh, the bastards deleted that video. God damn it. Just as I wanted to show you, they deleted that video. Somebody complained, some idiot that knows who complains against such videos. That's why I couldn't find it in the history. Let's see if I can find it. Cover shop, what was the name? Okay, I found another one. Now back to the class. I wonder, why do I like it so much? I am pretty sure it has to do with several factors. I'm inherently a sadistic person. That's one of them. And that's why I teach mathematics. And secondly, the very beginning of it as a manual, you know, graduating from a class to become a forklifter. It makes me think of the university. Yeah. Who, me? I don't know. I mean, the guys, who else would be doing it? Yeah. Now, I hope you had a good rest from the material, because now we continue with the same thing, but it's called implicit differentiation. I'll send you the link in case you want it. This one is actually better resolution than somebody sent to me. So here is, guys, the next situation that we are considering. So you are hopefully already used to the idea of differentiating when you have an explicit formula. Yes, but do you remember what is the derivative? How do you say that? In German they say im Grunde genommen, taken at taken at base plane level, taken at ground level. What's a good word for it? So what is the derivative? What's the gist of it? What's the tachlis of the derivative? It means that you zoom in on a curve and you will see a straight line, correct? Straight line. Now, do you see, guys, this is a circle. Its equation is x squared plus y squared equal to 25. Yes? And what? And of course, this is not y a function of x or x a function of y. Do you see why? Given a particular x, there are two possible outputs. Also, if you fix a particular y, there are two outputs in the x. So you cannot write the circle as a function of one of the variables. Do you see that? Nonetheless, you can ask yourself, is the curve differentiable? And what do you think? Is the curve differentiable? And would you type in the comments, please, what is the question asking? Guys, curve differentiable. What's the idea of differentiability? You do what? You graphically zoom in on the curve. And when you zoom in on the curve, you see a straight line. And if that's the situation, then the curve is differentiable. Yes? Exactly. Check if it's smooth and differentiable. So here, when you zoom in at the point 5,5, you will see a straight line. And this, of course, this problem has very historic significance, guys. Through centuries, people used to think the Earth is flat. Do you understand what they used to confuse? They confused the stand double, the tangent plane, with the global shape of the object. Do you understand? So the circle is a one-dimensional version of a sphere. And zoom in at a particular point and you see a straight line. So what is that thing? How can I find the slope here? One observation is, look at it, guys. I don't need to consider the lower part. I can take this red box and I can take the box as small as I want. I have to just focus it locally around the point 5. It should not be 5,5, by the way. It should be, so I made a mistake here. I said it's x squared plus y squared is 25. 5 squared plus 5 squared is not 25. It should be that over root 2. It should be that multiplied by root 2, but that's another issue, okay? I made a small mistake here. It's 5. The coordinate should be actually, the coordinate should be 5 over root 2, 5 over root 2. Then the point is on the circle, not what I wrote. Clear? Because 5 over root 2 squared is 25 over 2, plus 25 over 2 is 25. That's fine. So there was a glitch here. So if I zoom in around this curve, look at it. If I were to zoom in into this red box or into a much smaller box, then if I select a particular x, there is a particular y output. In other words, locally, the circle is a function of x. Now I can solve the slope of this tangent either explicitly or by the next technique, by implicit differentiation. Let's first try to understand what is explicit differentiation here. How do I do that? So here is what I do. So I have x squared plus y squared is 25. Y squared is 25 minus x squared. Do you agree? Oh, great, Darul, you're back. So anybody else, guys? Come on, I want to see your faces. Give me some joy. So we have that y squared is 25 minus x squared, and that means if I take the square root, it's y equal to plus or minus root of 25 minus x squared. But I know that my y is positive, so I select root of 25 minus x squared. Do you agree? So the local function that I need to use to find the slope of the tangent line, to find the local linear approximation, the stand double as I call it, right? What the curve looks like locally is this. It's root of 25 minus x squared. Take the derivative, and what do you get? Look at it, guys. Take the derivative of this function. You get by chain rule 1 over 2 root of 25 minus x squared times the derivative of the inner function, which is minus 2x. The 2's cross out, and you have minus x over root of 25 minus x squared. Observe the following. Do you see that on the denominator, I see y of x. So the derivative is minus x over y. Do you follow? You see my formula, I can reduce it to the expression minus x divided by y. Good? Very nice. Now this is, guys, this is something that people find difficult. So make sure you understand what I'm saying. So look at it. So then, although I plugged the wrong points, the right point to plug in is 5 over root of 2 divided by 5 over root of 2. The slope ends up being minus 1. The root of 2 just canceled. So really it should be 5 divided by root 2 with a minus. That's the x coordinate. And the y coordinate is over root 2, so it's 5 over root 2. The reason, even with my mistake, that I got the right answer is that the root 2 crossed out. You understand? Root 2 was anyhow crossing out. So the slope is minus 1. You follow? Do you see how I obtained explicitly the slope of that curve to be minus 1? Which means that if you were a very small creature flying to this planet or to the circle, and you landed here, you will think that you are at a line that is at an incline of 45 degrees downwards, right? Y equals minus x, or it's the slope is minus 1, means that you're inclined this way at 45 degrees, sloping down. Good. The reason you don't slide and you don't notice that slope is that you think that down is to the center of the earth. So you always think that you are flat. You understand? For you, down is always to the center of the earth. But from the perspective of seeing it on the side, if you zoom in and you kept the same perspective, it would look to you like you're at an incline of 45 degrees. Now let's solve the same problem, but this time we are going to do that implicitly. Now, implicitly, guys, the idea is this: we are not going to bother solving for y. We just pretend that we carry that stage. Do you understand? Can you pretend that you actually carry the solution? You see, here we did algebra. Here we began by saying x squared plus y squared is 25, and then that y squared is 25 minus x squared. And I took the square root and I obtained an explicit formula. But now we can skip that step and try to do it with the assumption that we have the formula. So look what happens here, guys. In the original expression, I have x squared plus y squared is 25. Now, do you see why I wrote y of x? Because if I were to solve for the formula, the y will disappear and I would see a formula only involving x. In other words, in this particular case, it would be root of 25 minus x squared. You see? Francis, I'm not sure why is there a division there, or what do you mean, right? So here I have x squared plus y x squared equal to 25. That's a function of x. Now I can take the derivative of the left and of the right. What's the derivative of the left? It's 2x. And what's the derivative of y squared? It's chain rule, guys. You understand? It's square function that has eaten another function of x, which I just labeled here as y of x. Can you see that? It's really it's square of root of 25 minus x squared that I'm taking the derivative. But I did not explicitly find that solution. So I just have to do this. Derivative of the outer function is 2y times y prime. So it's 2 box prime. So this is what I get. So I get that y prime of x is equal to, just moving things across, I just isolate this part, you see? It's going to be minus 2x divided by 2y, you see? Just move this across and divide by 2y. So it's minus 2x over 2y, which is, again, minus x over y. I got to the same exact place, but I did not spend any time solving for y. You understand? I just pretended I have. It's a sort of cheating. The slope I still obtain to be the same. Here is another example, guys. Can you help me with this example? So here we have y squared plus 4x squared equal to 4xy. Let me write it for you. So we have a curve that's described, we have the curve y of x. We don't know it, but we know that x squared, what was that curve again? It y squared plus 4x squared, so okay. But we know that y squared plus 4x squared is equal to 4xy. Yes? I want you to tell me using, let's try two methods. First, you're going to try to find the derivative explicitly. Okay? Find slope of tangent line to the curve yx at 1, 2. Doing it first explicitly. Do you understand what I'm asking, guys? You have this curve, you don't see it. It's identified by this equation. You are zooming at this curve to the point 1, 2, and you have to find what is the slope of the ensuing lines. I mean, you're going to begin to see the stand double, the line. What slope will it have? What's the derivative there? If it's explicit, it has to be a number because you're solving for what? You're finding the slope of the tangent line, yes? You can find the tangent line if you want to. Maybe we should do that. What's the tangent line to this curve? So explicitly, guys, what do? Do you recognize this formula? This is y squared plus 4x, what's it, minus 4xy. Minus 4xy plus 4x squared equals 0. Okay, and then what do we have? We have that this equation just reduces to y. It's a perfect square. Do you see that? It's y minus 2x squared equals 0, which means that y is equal to 2x. Do you see? The explicit formula is that this y that satisfies this equation is a line. This equation is really identifying a line. Do you see that? I can solve it. I realize it's a perfect square. And I see that y is equal to 2x. Anna mentioned that. Do you see the rest of you? Yes. Y is 2x, which means what is that slope without any need to calculate further? Y equals to 2x. It means I zoom in on the curve at the point 1, 2, and I see what slope. Type in the comments. Two. Very good. So the slope is slope is 2. Now, second part is let's try to do that implicitly. Implicitly means that I am not solving for y, I'm skipping that step. So it's y squared plus 4x squared is equal to 4xy. I'll do this one with you together, guys. Do you understand what it means to solve this implicitly? It means that you pretend that you have obtained a formula in terms of y in terms of x. You just do not see it. Giovanni, y is equal to 2x. So you pretend that you solved it. So then you have here really y of x. You just suppress the fact that there is an x, right? And here you have also y of x. You just suppress it. Yes, no worries. Clear? You understand what is implicit differentiation, guys? We just carried out an explicit computation where we figured out. I hope you understood it, guys. I hope you recognize perfect squares and you understood what I did here, yes? It was very simple. It just was a perfect square. It just was y minus 2x squared equal to 0. And the only way that can happen is if y itself equals to 2x. So my formula was simply y equals to 2x. It's a line that satisfies that quadratic equation. What is it, Francis? The it refers to what? So here, I pretend that I solve the equation. Well, if you solve it, yes. But so you see what we pretend that we have a formula. But we see the formula even though we haven't taken the steps to obtain it. That's why it's called implicit. You understand? You will see, if you solve this equation, somehow you will see a formula. But since you haven't carried it out, you only imagine that you see the formula. You imagine seeing something in terms of x here. So then what's the derivative? When I take the derivative of this side, that will be the derivative of the other side, of course, because they are equal. What is the derivative on the left, please? Could anybody write the derivative on the left to the best extent you can? To the best extent you can, write the derivative of the left side. Okay. So let's see what we get here. The derivative of the left side, guys, look at it carefully. It's 2y multiplied by y prime. You understand why? Because we have square of a function that I do not know exactly what it is. It's something in terms of x. So how do I take the derivative? I apply chain rule. It's the derivative of the outer function, which is 2 times the inner function multiplied by the derivative of the inner function. I can only write y prime because I don't know what is y. I mean, when I solved it explicitly, I know y is equal to 2x. But if I didn't do that, I would not have an explicit formula. And I can just write y prime, right? The derivative of y is actually 2 in this formula. Chain rule, because it's, look at it, it is y of x squared. It's this function. Squared. Good. So I just suppress the x. There is no y there. That's just the formula that we would have gotten here if we solve the equation. It would be 2x squared. But I don't know the formula, and I apply chain rule. So what do I have next? Next here is plus 8x. Now help me solve the other part. How do I expand the other part, please? Okay, thank you, Christiana. So here we have product rule. Do you see that? It's 4x times a function I don't know. So when I take the derivative, it becomes 4y plus 4xy prime. The primes is what I'm interested in solving. I want this part to be isolated and this part isolated. Yes? So when I move those parts aside, what do I get? I get simply 2y minus 4x. So I have here 2y minus 4x. I just move this across times y prime equal to 4y minus 8x. Yes? And what do I obtain? Once I divide both sides by 2y minus 4x, I obtain that y prime is equal to 4y minus 8x divided by 2y minus 4x. And do you see that this ratio is exactly 2? If I multiply denominator by 2, it will be the numerator. So the ratio is exactly 2. And I obtain that the derivative of y is 2. Now, if the derivative is always 2 for y, that must mean that y is 2 times x plus a constant, right? Because the slope is everywhere the same. That means that the minute line segments that built up the curve are all aligned to form a global line. Do you see that? I hope you remember what we talked about the derivative and how the graph of a function is made out of tiny lines, and the derivative is describing the orientation of the lines. If the slope is always the same, so for example, here is an example of a non-constant derivative. Here is one slope here, and then here is another slope. It's a non-constant function. But if all the tiny microscopic line segments have the same slope, it means that they are forming a chain that together is a line, a global line. Do you see that? Beautiful. So look at it. This was implicit. This was explicit. Here it is again. So as it happens, most equations, guys, are going to be that you find in the wild in nature are going to be terribly, tremendously difficult, impossibly difficult to do explicitly. So here is an example of it. So suppose I asked you to find an equation of the tangent line to the curve x cubed plus y cubed equal to 6xy at the point 3, 3. I hope you recognize that this is a cubic equation. You understand? If I move everything to one side, I get a cubic equation equal to 0. If I were to solve it directly, by the way, do you know how to solve cubic equations? I bet you do not. Am I right? How is there anyone in this class that knows how to solve cubic equations? What is a plus b? How to solve cubic equations? No, that's what you mean is this, I think. There's a difference of third powers, guys. You should all know how to factor a minus b cubed. Okay, that's not what I asked. A minus b cubed, it's a minus b multiplied by a squared plus ab plus b squared. This you all should know. You should remember the Nightingale and the Rose by Oscar Wilde. And this is not what I asked, right? So a minus b to the power of 4, it's a minus b times a cubed plus a squared b plus ab squared plus b cubed. This you should all know. What I asked you is, you know how to solve this equation, x squared, so ax squared plus bx plus c equal to 0. This is quadratic. Quadratic equation, right? Now, a cubic equation is ax cubed plus bx squared plus cx plus d equal to 0. That's cubic. Does anyone here know how to solve cubic equations? Well, you're silent. I presume you do not. Right? And in fact, quadratic equation, it's very possible to derive the formula. The quadratic equation, it's possible to derive the formula very fast. You understand? I can derive the quadratic formula within a minute or two. But the cubic equation is entirely different. Quadratic formulas were solved by Babylonians, I presume. You know, it took thousands of years for a method to be developed. It was developed during the Renaissance. It was tremendously difficult. So cubic equations are tremendously difficult. And in the 19th century, it was proved that for degree 5 and onwards, a general formula in terms of radicals is impossible. So it gets tremendously difficult with increased degrees. So if you had to solve this equation, x cubed plus y cubed equal to 6xy, explicitly for y, synthetic division, I know what you mean, equal to 6xy, this would be tremendously difficult to obtain. And here is how the formula would look like if you found an explicit formula. Here it is. That's the explicit formula for y after a lot of labor, and I'm sure I would be very impressed if anyone would be able to do it in this class. It's not easy at all. And so this is the formula. Look at it. It's the cube root, and within it you have a square root, and that's just the formula for y. Forget about its derivative. And that's not at all the most difficult type of formulas that arise in applications. So it's much easier to use implicit differentiation here. Do you see why, guys? In implicit differentiation, I pretend that I obtained the formula. I pretend that I went through the labor of getting the explicit formula, and I just imagine that it's there. So when I see the y, I imagine there is some sort of formula in terms of x, like I see over here. And I differentiate, and I then differentiate. Look at it. What's the derivative of x cubed plus y cubed? It's 3x squared plus 3y squared times y prime. Do you see why it's times y prime? Because this is chain rule. Y, as you can see, it's some sort of formula. Yes? Are you with me, guys? It's a difficult topic. Are you understanding what I'm saying? Yes? So do you see why there is a y prime appearing? Everybody says that? Why I have multiplication by y prime? It's because I pretend I have a formula, but I don't, and I then apply the chain rule. So we have 3x squared plus 3y squared times y prime is equal to, this is product rule, 6y plus 6x y prime. And my goal is, again, to solve for y prime, to find the derivative here of this expression, and to find the slope at the point 3, 3. Good. So look what I do here. I move everything that has a y prime together, and I move everything that does not have a y prime to the other side. So I have that 3y squared minus 6x times y prime is equal to 6y minus 3x squared. You see, all I did is I moved the 6x y prime across, and I moved the 3x squared across. And so that y prime is 6y minus 3x squared divided by 3y squared minus 6x. Do you see that? Now, if I plug the point 3, 3, it's 6 times 3 minus 3 times 3 squared, whereas here it's 3 times 3 squared minus 6 times 3. You can see that this and that number are the same, this and that number are the same. So that means that this ratio is -1. You see that it's just -1. It's a basic algebra, guys. I explained that because I'm not sure, right? Do you follow what I'm saying? You have to be good at algebra to a reasonable extent for this class. Yes? From this step, you understand the idea. The idea that is new is that we pretend that we have solved for y. And that we pretend that we obtain that formula, which is pretty difficult to obtain. It's like in that joke, you know, this joke about a mathematician and engineer. So you have a can of soup floating to an island where a mathematician and engineer are stuck and they're starving. So then the engineer begins trying to figure out what to do. How do you get the food? And then when he busy from his work, he looks at the mathematician and he's already finished eating the can of soup. And he asks him, how were you able to do it? So what does the mathematician say? He says, I had a brilliant idea. I assumed I have a can opener and I work from there. Do you understand? What's the can opener in this particular problem? I assumed that I solved for y and I work from there. That's the can opener. You understand? That's the idea here. So you see, I can solve it. I get that the answer is -1. And so the equation of the tangent line is y minus 3 equal to the slope, which is -1, x minus 3. Good. Now it is your turn. How I got 3x squared? 3x squared is the derivative. Look at it. I have x cubed plus y cubed is equal to 6xy. That's the defining formula, defining equation that identifies the curve. So when I take the derivative of the left part and of the right part, I still keep equality. So the derivative here is 3x squared plus what's the derivative here? It's 3y squared times y prime. Yes? And that's equal to 6y plus 6xy prime. Here I use product rule. You understand? The y is there is no y. There is some formula in x. It's just maybe a scary formula. I don't see it. It's something like this. That's the idea. You see? So it's because I haven't solved for it, I don't have an explicit formula. That's why you call it implicit differentiation. So I pretend I have the can opener. I pretend I have the formula and I solve it from there. And I just recognize its chain rule. You all follow me, guys? So don't focus on the letter, just focus on the idea. What is y cubed? It's the formula that I need to find derivative for cubed. All right. Now, if you would like, guys, you know, our time is approaching to end. But let's see if we can solve this question. Sine of x plus y equal to y squared cosine x. It's very, very difficult to solve y prime explicitly, but you can solve y prime implicitly. Can you do that? Can you find what's y prime out of this equation in terms of x and y? So let's do that in the next 5 minutes, and I'll be right back. All right, let's see what we have there. Okay, ready, guys? So here is the situation. We take the derivative of both sides. What's the derivative of the left side? It's cosine of the inner function times the derivative of the inner function. Make sure to write parentheses. It's 1 plus y prime. What's the derivative on the right? It's 2y y prime cosine x plus y squared times minus sine x. You see, it's product rule and chain rule when I take the derivative of y squared. Do you get it? The rest is just algebra. Just group together y primes and group together everything on the other side that does not have y prime. And when you simplify, this is what you will get. You understand? The main step is here, and then of course careful algebra. What we will do next class, we will have a competition. We'll see how fast can you solve those functions against me. How fast can I solve them? Good. So train, see if you will win. Goodbye.